Hello, everybody, and welcome to Dot to Dot. Today, I'm going to show you the geometric progression that goes from the right side of the Oak Island map to the left side to the Oak entrance that is created by anomalies, drawings, and different kinds of misspelling and grammatical errors. So let's get started, and we'll go up to the Rashford note, and I'll give you the two geometric vectors that are found from that. So the first geometric point comes from the L in La Rochefoucauld, which is very misplaced up next to Francois with no spaces, and the V in Ver, and this is separated from air to create a wandering line, and then a hash mark that has a little barb which denotes the V, and you line this up and it goes to the center of the quadrant, and this is your first vector. Okay, so your second vector comes now from the combination of petite and set. Now, petite is misspelled, and it's E-T-T-E, just like set, and there's a little restored I put in there. And that little restored I, and then there's also a E that is emphasized, and that will come into play later. But then we go over to set, and this is misgendered. It's supposed to be say, but it's E-T-T-E to match the petite. And you put the first vector starts where the I would be in petite. You insert that in there. Now, this vector from the set drops down through the R and past the D, and it ends up down at the E, like emphasized in petite, and it's tangent with that. And now we're going to go to the next clue, which will join up with this vector from the set line. Now, the clue associated with the set line is the fish symbol. Now, this fish symbol is very interesting. It's very detailed with an eye and what it can be interpreted as a phallus. Now, when you take the phallus, the eye, and the fish, this relates to the mythological legend of Osiris, Isis, and Horus. Now, if you take the phallus and you take a vector tangent to the eye, which is the eye of Horus, it creates a vector angle to the point that intersects with the set line. Now, this point will be very critical in getting the distance of the master scale, and we'll talk about that later. But now we're going to go over to the upper left-hand side of the map to the or the round island. And on Round Island, it has two very anomalous, what we call uh, tick marks and a vector line. Now, this is very interesting. This vector line is going to be a vector that goes down across the map. And the other symbol is an associated symbol to the east arm of the quadrant. And it will be a measuring point on the quadrant, and it will be associated with this vector. So if you take this vector all the way down, it goes to a very important drawing, which is the Thales theorem drawing underneath the word sept in the 1347 number. Now, I found it very interesting that this vector from Round Island goes down to and points to this important drawing, and we're going to see how important it is. But it also gives us a reference to the tick mark on the uh, east arm quadrant, which is associated with the bark, and that's the next vector that we're going to do. And the vector from the bark is basically given by the lightning bolt, which points to the bow, the point of the bow, and the rudder, which is where is a little notch there. And you line that up, and it gives you a vector that intersects the uh, round island vector. Now that we have two intersecting vectors, it creates a pair of vertical angles, which we will now bisect. And when we bisect those, we're going to have a point in the center. And from that point, we're going to make a perpendicular line a certain distance. Now, this distance is a measure from the quadrant, the east arm tick line, to the center of the quadrant. So that distance from the quadrant is going to be duplicated from that point perpendicular. At this point, we're going to go back down and reference the drawing that is underneath the sept. And I'm going to show you a connection here with that drawing and the quadrant west pointer. And this triangle in the drawing is associated with the pointer triangle on the west arm. And notice there's a line that is drawn at the base of the triangle in the small drawing, and we're going to do that same thing. We're going to take that line at the base of the big triangle on the west pointer and bring it over to that extended line that was the perpendicular from our initiation point with the two vectors from the bark and round island. So now what we're going to do is we're going to go from the point, the end of the quadrant measure, and we're going to draw a circle that will be the center. And notice how it goes up to the point that we just created with the perpendicular line and the west arm pointer. And notice it also goes through the center of the quadrant. Now, this point is what we're going to call the hump, and this is from the formula. Now, the second distance is from the base of the west triangle pointer down to the center of the quadrant. And that is transferred over from the extension point down towards the center there. And we make another point. So now this axis, we'll call it an axis, is segmented into three sections. We also notice that the 432 circle intersects the round island vector. So we're going to go down back to the Thales drawing, and we're going to see that the line that is coming from the base of the west pointer triangle is going to go down to a point. Now that point is going to be the landing point for the set and the fish vector, and this will give us our master scale. So the master scale is written in French and translated it is 1347. Now 1347 is equal to 1440 Scottish feet. Now that's a different video, but when we take that line down to the landing point from the 432 extension, this is the value that we can take now and calculate the distances in the segment. The three segments are 288, 432, and 144. So now we have taken the information from the bark, which is our resource of information. We've constructed and unloaded it and taken it to the bateau, which is the boat. So now that everything is in the boat and ready to be transferred to the left side of the Oak Island map to Oak Island. Now we're going to reconcile the Ver line to the quadrant that comes to the center of the quadrant. And we're going to take a line from the center out through the Nord arrow point, and it's going to go tangent to the O in Nord out to the end of the N. Now, this is going to be a distance to the entrance. But notice also that it is a 45-degree angle. Now, if we're going to take the var line past the quadrant center and to the axis, we're going to find that the angle of the var line to the axis is 30 degrees. This is important because it gives us orientation when we transfer what is on the quadrant side to the Oak Island side. Now that we have our constructed values on the quad side, we're going to transfer them to the drawing of Oak Island using Thales intercept theorem. Now, Thales intercept theorem is shown here where the proportionality of B to F is equal to the proportionality of A to E. Now, this intercept point is S, and with the values, we're going to drop a line down to an intercept point from the 288 marker, and this will give us the start of our Thales intercept theorem. Now, from the endpoints of the quadrant axis, we're going to converge them down to the intercept point. This is what we call triangle 1. One of the most fascinating aspects of the Oak Island map is the convergence point is at the beginning of the vault under the earth lightning bolt. This is truly amazing to me. And what's going to fascinate you even more is the next icon, which is triangle 2. So what's fascinating about triangle 2 is you can see the converging line is going through the top vertice of the triangle icon. What's even more fascinating is the other vertice will serve as a direction line for the parallel line. This line has to be parallel with the quadrant line at the top in order for Thales' intercept theorem to be valid. So when this parallel line is completed, now we have another triangle, which is triangle 2. And I think this is why the icon is named triangle deuce, which means triangle 2. Now that we have the Thales intercept set up, we're going to transfer the information from the quad side to the Oak Island drawing side. And we're finding the importance of the intersection between the north line and the parallel line through the lightning bolt on the triangle 2. Now, this point divides our parallel line into two distances, 288 and 576, that are proportional to the quadrant data. Now, at this point, we're going to draw a circle that is equal to the distance of the parallel line, which is 864. So half that will be 432. And where it intersects the parallel line, we're now going to put a point there. And this divides the segment into the proportional division from the quadrant side. So from this new point, we're going to draw another circle with that being the center. And the radius is going to go back to triangle 2. Now this radius will be 720. Now where this circle intersects the converging line going through triangle 2, we mark that point. And we're going to take a line and connect it through the second point all the way to the diameter of the circle. So now this circle is a diameter of 1440, and we have an axis line with the master scale distance that is proportional to the data from the quadrant. Now we can start segmenting our axis that is on the drawing of Oak Island, and we know the radius of 432. So we'll draw that circle and mark our 2 points on the axis. And we also know the segment of 144. So we will draw a circle there and mark our point on the axis in the proper designation according to the quadrant for 144. So now we're going to go to a place where it says, do not go here with the boat. And it begs the question, where do you go with the boat? Well, where we go is according to the quadrant west. So it's pointing to this eye, and we're going to take the dot of that eye, and we're actually going to make 2 lines, one at the bottom tangent of the eye dot and one at the top tangent. And we're going to go west. So these 2 lines that run due west, the bottom one intersects the north-south line at the axis, and the top one is actually the Ver line according to the quadrant data. Both of these are 30 degrees from the axis, so the axis is now running at 60 degrees. So, as you probably guessed, we have the axis of Nolan's cross now transferred proportionally according to the sacred numbers that were actually proposed by Brian Farrow. And now we're going to put this lattice. Now, this lattice has been used since medieval times for architecture, for land survey, for any kind of mathematical design. And we're going to put a few key points on there. We're going to put cones B and C. And we're also going to put the center of the quadrant, which was La Hamp. And we'll also put the south anchor. And notice where their positions are located on the lattice. They're right on the lines. And this is a tool that was used for design for centuries. So now we're going to draw a line according to the quadrant, and we're going to go from the point, which is actually cone A, and we're going to go through the point, which is La Hamp, which was the center of the quadrant. And we're going to make this line the distance that is proportional to the north pointer line on the quadrant. And at the end of that will be the entrance, which was at the top of the N in Nord on the quadrant. So if you notice that the entrance is well within the circle of the oak enter here, and the line is actually bisecting this oval. So now we're going to take away the lattice and we're going to restore the east-west line. And if you notice, it goes right through the point called La Hamp, which was the center of the quadrant. So let's remove our parallel transfer line. And if we measure the angle between the east-west line and the entrance line, it is 45 degrees. So this is according to the quadrant data. So now we're going to just label all the points on Nolan's cross that are according to the quadrant and also the points according to the Oak Islands map. So thanks for watching this demonstration where we took the data from the right side of the map, the quadrant, and transferred it through the bark onto the boat to the Oak Island drawing on the left. Thanks for watching, and I'll talk to you later.